Okay. So tell me what we discussed in the last class. Yes. Okay. So till now we have completed 4 sessions for complete basics. Okay. So in the first session we have discussed about atoms, molecules, matter, and the next quantity, expressing ways to like how can we express quantity like moles, like that right now. So after that slowly we have moved for periodic table and its properties we have discussed, and then next slowly we went to chemical bonding. Okay, and the next what we discussed, organic chemistry, and you also like you got complete IUPAC nomenclature also right now. So now from today onwards we'll start our discussion on mole concept. Okay, means till now we already discussed mole concept. Using the same thing we will be moving forward for the continuous topics of that chapter. Okay, what is the first chapter name? Some basic concepts of chemistry. Okay, so in some basic concepts of chemistry, what are the topics to be studied here? See, firstly let me tell you, first thing is so first thing is mole, means we can simply say it as mole concept. So what it is, a mole concept means it deals with the quantity of substance. Means for example I am giving you some weight, so how can you convert this weight of a substance to the number of moles? I will tell you again what do we mean by mole. Okay, so those who have joined late, those who missed the last that basic classes, don't worry, I am going to repeat those things whenever it is possible, like wherever it is required. Okay, so first the given substance into number of moles. So that what is the use of this number of moles? Now we can say that in the given amount of quantity, for example I am giving you some 5 grams of hydrogen, then number of hydrogen particles in that 5 grams. If I ask you, so you can say number of particles, number of like particles or entities or whatever it might be. So this kind of conversions comes under this mole concept. For example, I am giving you some 10 grams of hydrogen gas. What I am giving you? 10 grams of hydrogen gas. Now how much quantity or how much volume this 10 grams of hydrogen gas will occupy? That is volume of hydrogen gas required to put this 10 grams, or how much volume it will occupy at particular temperature and pressure. That is what we are saying at STP condition. 10 grams, like 10 grams of hydrogen will occupy some specific amount of volume. So all this comes under the discussion of mole concept. Up to here it is clear? Okay. Then next, after understanding this mole concept, we are going to study about stoichiometry calculation. What is that? Stoichiometry calculation. So stoichiometry calculations means what? Yeah, see, we will be doing chemical reactions now. For example, combustion of like any hydrocarbons, like combustion of fuel means you are taking like LPG you are taking. What LPG contains? It contains butane, butane, like isobutane, propane, like that hydrocarbons it contains. And also we know there is something like natural gas. What is that? Methane is there. So all this comes under fuels. Like if I say petrol, what it is? It is like octane, isooctane composition will be there. Okay, so now all these are what? Like hydrocarbons are carbon containing compounds. Okay, so generally we are considering them as fuels. So fuels means what? They will produce some energy upon combustion right now. So now upon combustion of coal, what is this? Coal means carbon. Okay, upon combustion of coal, what it will produce is carbon dioxide gas will be produced. Okay, for this purpose what we require, oxygen is required. Yes or no? So C plus O2 gives rise to CO2 you are saying. So now what this stoichiometry calculation do here? See, the amount of CO2 gas produced when I take 12 grams of carbon, or the amount of CO2 gas produced when I take 6 grams of carbon. It means if I take only 6 grams of carbon, how much CO2 gas is produced, or how much oxygen is required for combustion of 6 grams of carbon. So this kind of calculations can be done using this. Is this clear? What is the use of stoichiometry calculation? To calculate amount of product formed or amount of the other reactant required for that reaction. Okay, so this kind of relations we'll get. Okay, so when we are doing this stoichiometry calculations, we need to follow some basic steps. Okay, so what are those basic steps? See, for example, methane is there, ma. So let us go with very simple one. C plus O2 gives rise to CO2. I am saying this is a very simple reaction. Next, methane plus oxygen forms CO2 plus H2. Okay, right. Now see how many carbons are there at the reactant side. So I hope you know this is reactant side, this is product side. So reactant side, how many carbons are there? 1. So product side should also be same number of carbons. So here 1, here 1. This is perfect. Next, what about hydrogens? Here how many are there? 4. There? 2. So it means where it is less? Product side. How many are less? 2. So if I multiply this with 2, 2 to the 4. Here also 4. So carbons balanced, hydrogens balanced. Now who else? How many are there this side? See here, one CO2 means it contains 2 oxygen atoms. Oxygen atoms. Oxygen atoms. Then next, here how many are there? 2. So total oxygen atoms are how many? 4. So here what should be the number? Here already 2 is there. So I can multiply with 2. 2 to the 4. So 4 oxygen atoms are reactant side, 4 oxygen atoms product side. So like this, you need to balance the reaction first. What we need to do? So now we have balanced it properly? Yes. So up to here is this clear? Okay. So after balancing, what are these coefficients they have? See, there is nothing means here it is 1. Okay. So what is the coefficient here you are saying? 1. For this, 2. For this, 1. So this, so these coefficients we have there here, those are considered to be stoichiometric coefficients of that particular reactants and products. Okay, it means a chemical reaction takes place with respect to that stoichiometric coefficients. Okay, you need to balance the chemical reactions whenever we are doing these calculations. Okay, now see here 1 is there, 1 methane molecule you are seeing. So it means you can understand the reaction like this. 1 mole of methane, what I am saying? 1 mole of methane requires 2 moles of oxygen. Requires 2 moles of oxygen and forms 1 mole of carbon dioxide and 2 moles of water. Is this clear? Okay. So now in the last class that number of moles formula is there now. So what is that number of moles formula you have studied? Weight of a substance by molar mass of a substance. So by using this we can also relate number of moles to the weight and all those things we can do. Okay, up to here it is clear. Okay, we will come back to the stoichiometry calculation later. Okay, let me introduce a few other things also. Okay, so as of now we will first finish this, and you know in the EAPCET definitely one question from here. Okay, so from today's discussion definitely you can expect one question in the exam. Okay, whether it can be NEET or EAPCET, and you know for complete chemistry mole concept is very important. So without understanding mole concept you cannot calculate any other topics of chemistry. Okay, whether it can be physical, inorganic, organic, everything requires mole concept. For example, see you are doing an inorganic reaction. So there also you need to balance the reaction. No? So where you are studying it? Here itself in the mole concept. Like that, whether it can be physical, organic, anywhere you will be seeing mole concept calculation. So please try to focus the session. Try to focus the session completely without missing anywhere. If you have felt anything is missed, you ask me there itself. Okay, so first thing is mole concept, then calculations, methods to calculate number of moles and few numericals related to that. The next percentage composition. What do we mean percentage composition? In the last class we have did now, like I have given you urea. What is the urea formula I told you? CO, NH2, NH2, like this I told you. Then calculate percentage of nitrogen I asked you. So that comes under this percentage composition. And after that there is something called empirical formula, molecular formula. If you remember, you have studied this for 4 marks question in your first year IP. Okay, we will discuss that. Next, previous year questions from this mole concept. That's it. Okay, let's go through the session. Yeah, so first one, this one, mole, means we already have clear discussion, clear understanding of mole. What do we mean by mole? Okay, so again this is a definition. Anyways, here we'll see here. See, in the simple way, if I say a pair of shoes, what do we mean by that? Two shoes. Okay, similarly a dozen eggs. A gross of pencils means 144 pencils. Similarly, if I say a mole of hydrogen atoms, so a dozen, how you are taking this dozen as 12, take a mole as 10 power 23. So this much big number, when I say 1 mole, 1 dozen means you are taking 12 particles. Similarly, if I say 1 mole means this many particles. Okay, it can be anything. Okay, so why do we require this much big number? Because if you take any quantity, any chemical substance you take, so if you catch a little bit chemical substance, it contains very big number of atoms right now. So in order to discuss about all those things, we are defining them in simple term as moles. Okay, see, every time you are taking this much big number, it is difficult. So we can say in terms of moles. Okay, is this clear? Yeah. So that's it. Do not confuse or do not think what do we mean by mole. See, I am saying frankly, those students who only prepared for IPE previously, okay, so they will be in full confusion in understanding the word mole itself. చాలా మందికి మోల్ అంటే ఏంటో అర్థం కాదు. బట్ ఇది ఏమన్నా పెద్ద కన్ఫ్యూజన్ టాపిక్? జస్ట్ మోల్ అంటే మీకు ఏం తెలియాలి? సో whenever someone says a mole, what does it mean? Avogadro number. So this big number is there now, that is called Avogadro number, indicated with symbol Na. Avogadro number. Okay, 6.022 into 10 power 23. That's it. You just remember like this. Okay, we will move forward. Yeah. So now molar mass means what I told you? The mass of 1 mole of any substance is called its molar mass. Yeah. So the mass of 1 mole means this much big number. Is expressed in grams, then that mass is considered to be molar mass. Okay, it is also called as gram atomic mass for atoms, gram molecular mass for molecules. Okay, now what is the units for molar mass? Gram per mole. Okay. Okay, so if I take 6.022 into 10 power 23 carbon atoms, which atoms? Carbon atoms. So it will weigh how much? 12 grams. So if I take this many number of carbon atoms, which atoms? Carbon atoms. What is its weight? 12 grams. So this number I can simply say 1 mole. So if I take 1 mole of carbon atoms, it will weigh 12 grams. Is this clear? So now 12 grams is considered to be molar mass of carbon. Okay, like that. So now up to here it is clear now. So 1 mole Okay, so 1 mole means how much quantity we are saying? 12 grams. Okay, so up to here it is clear now. 1 mole carbon atoms means 12 grams of carbon. So now from here I am asking you, if I am giving you only 4 grams, then how many moles it is? I am giving you 4 grams of carbon. How many moles it will be? How can we do that? See, I am asking you how many moles it is, I am asking you right now. So what to do? So x into, we want to calculate this x value right now. So x into 12 equals to 1 into 4, like this. So x will be now 4 by 12. So it will be 1 by 3 mole. So how many moles? This 4 grams of carbon means? 1 by 3. So what you did, so in order to calculate number of moles, see what we did, number of moles only we calculated now. So number of moles, what is the formula? See, number of moles, let us indicate with symbol N, is equals to, what you did here, see, initially when I say 1 mole, what is its mass? 12. This is fixed. So now what I given you? 4 grams I have given. So I have given some quantity, given weight, I have given some weight to you now. Okay, so take that given weight in the numerator. See, that is what you did here. The given weight is how much you taken? 4. In the numerator only now. So given weight by what I have taken here? 12. So 12 means what? It is the molar mass of that substance. So molar mass. Given mass by molar mass gives you number of. Okay, so what is the first formula to be remembered? Number of moles equals to given weight by its molar mass. That's it. Okay, up to here it is clear now? Right. So what is the first formula I have given? Number of moles is equals to weight of that substance by molar mass of that substance. Okay, up to here it is clear. Okay, so for mole the units will be considered as mole only. Okay, then next one. Let us take 2-3 examples so that you will feel clear. Okay, so now I am writing here. Methane is it. What is its molar mass? Tell me first. How can we calculate that? Molar mass. 12 for carbon, 4 into 1, so it will be 16. So 16 gram per mole is its molar mass. Now I am giving you 8 grams of CH4. Then number of moles is how much? So how can you calculate number of mole equals to given mass by its molar mass? 1 by 2. Half mole you got. This is your answer. Is this clear? Okay. Clear everyone? Yeah. So the next one, I am giving you 11 grams of CO2. 11 grams of CO2. Tell me how many moles it will be. Fast. Okay, and those who are in the live session, I have 2 things to share with you. So first thing, whenever you join the class, so if you understood it, you just mention clear in the chat box. And the next one, if you are really clear with that, you also click on the like button so that it will recommend to the other students. Okay, so this is the best way so that we can get more reach and you can also feel comfortable when you have like large number of audience in the chat box, right? So this is the thing you need to follow. Yeah, next, tell me here what will be your answer? 1 by 4. Okay, so number of moles, how can you do this? Weight by? So it will be 11 by? So how much it is? 1 by 4. So it is 0.25 mole also we can write. Is this clear up to here, everyone? Clear now? Next thing what I am saying. Up to here it is clear. See, if I take 1 molecule of methane, what I am taking? 1 molecule of methane. So in 1 molecule of methane, how many carbons are there? 1 carbon atom is there. Okay, in 1 molecule of methane, how many hydrogens are there? 4. So 4 hydrogens are there. So you are saying the number of atoms, number of hydrogen atoms, number of carbon atoms. That is called its atomicity. What is that? Atomicity. Okay. So now I will be asking you a question. So in 8 grams of methane, how many moles you got? How many moles of methane you got? 1 by 2. Half mole of methane you got. So if I ask you number of methane molecules, Number of moles means this is your answer. Now I am asking you number of methane molecules. What you will do? So I got, if I get 1 mole, that 1 mole into Avogadro number I should do. So that I will get number of methane molecules. So now here how much answer we got? 1 by 2. So 1 by 2 mole means Avogadro number now. So 6.022 into 10 power 23. So this many methane molecules will be there. So now tell me, this is 3.011 into 10 power 23 methane molecules. So similarly you tell me for this, how many number of CO2 molecules? 1 by 4 into 6.022 into 10 power 23. So upon simplification, what we are going to get? Number of CO2 molecules. Okay, up to here it is clear now, right? So the next thing is, they will ask you, so you got first formula as given weight by its molar mass. Second formula you got something like this. So 1 mole means Avogadro number you are saying. How much you are saying? Avogadro number you are saying. Now I am giving you some x number of particles. What I am saying? Then how many moles it will be? So x into this one into this one, like that, na? So it means, let me tell you one question. Let me give you one question so that it will be clear. See, 3.011 into 10 power 23 hydrogen molecules are given. Then number of moles is how many? How can you do this? First, so it's very simple. See how much number I have given? 3 into 0.11 into 10 power 23 H2 molecules given. The number of moles I am asking. See what you know, 1 mole means 6.022 into 10 power 23. So now which number I have given here? So 3.022 into 10 power 23 I given. I am asking you number of moles. Okay, number of moles I am asking. So it's very simple now. See, number of moles equals to, what I should do? This number into this number, this number into this number. So n into that Avogadro number, like Na. This one is called as Na, no? Avogadro number I told you. Okay, and this number into this one. So this is equals to 3.022 into 10 power 23. So from here what I can write? Number of moles equals to 3.022 into 10 power 23 by Avogadro number. See, Avogadro number means this number, no? Yeah. So now it's like what we are making here. We are making a generalized formula. See, this many molecules I mentioned, this many particles I have mentioned. So the number of particles given by Avogadro number gives you number of moles. Now the second formula you got it as number of moles equals to number of particles given number of, like it can be particles means molecules, atoms, ions, whatever they mentioned. So number of molecules or particles given by Avogadro number. So this gives you what? Number of moles. Now tell me what will be your answer for this? What? 1 1. Okay, no issues. Okay. So now tell me what I should do. So what is your answer? 3.01 by this Avogadro number. So it will be 1 by 2. So 1 by 2 mole you got. Okay, is this clear up to here? Okay. So now, is this clear or not? Yes. Yeah. Sometimes okay, so what is the second formula you got? Number of particles. just try to answer me this. This is a NEET 18th question, like 2018 question. Easily you can answer, I know. Okay. One question I will tell you before this, so that you will feel more confidence about the question. Okay. See, I am giving you methane, ma. What I am giving you? Methane. So how much quantity I am giving you is, let us take 1.6 grams. How much I am taking? 1.6 grams of methane I am taking. Then number of moles of methane I am asking you. What I am asking you?
Number of moles of methane.
This is first question. This always remember, N represents number of moles. Then number of moles of carbon also I am asking you. Then next question, number of moles of hydrogen also I am asking you. So tell me, how can we do this? Whenever I ask number of moles, so what is the data they provided for us? Weight is provided. Now what is the molar mass?
16.
So 1.6 grams by 16 gram per mole. Gram cancel. So 1.6 by 16 means how many times? This is 10. So this is 1 by 10 means 0.1 mole. So what is your answer? Number of moles of methane means 0.1 mole. If I ask you, even if I ask you number of number of methane molecules, number of methane molecules. What I am asking you? Number of methane molecules. So what will be your answer? Number of moles of methane into Avogadro number. So what will be your answer? 0.1 into 23. So now 0.1 is there now. Here 10 power 23 is there. It means you are multiplying 10 into 10 into 10 like that up to how many numbers? 23 times you are multiplying. So 110 I am removing from here and multiplying this with this. So numerator 10, denominator 7. I can remove this and I can write here. So what will be your answer? 22. Is this clear? Like simplifying is also clear or not? Everyone? Yes. Now this is about what? Methane molecules. Now in one methane molecule, how many carbon atoms are there? One carbon atom. So similarly, in one mole of methane molecules, how many moles of carbons will be there? 1 mole only. Okay. So what will be your answer for this question? Whatever the answer you got, like number of moles of methane you got, same answer will be there for number of moles of carbons also. Why it will be same? Because 1 mole of methane contains one molecule of methane contains 1 carbon atom only. Similarly, 1 mole of methane contains 1 mole of carbon atoms only. Here how much quantity I got? 0.1 mole of methane. So how many carbon atoms will be there? 0.1 mole of carbon atoms. So it will be also 0.1 mole of carbon atoms. Okay. Now if I ask you number of, like mole is there now number of carbon particles, if I ask atoms, this mole number into Avogadro number 6.022 into 10 power 23. Similar to this you will get the same answer. Okay. Now if I ask you for hydrogens in the same quantity, like same methane I am asking you. See, 1 molecule of methane contains 4 hydrogen atoms. This 1, 4, all these are called what? Atomicity. Okay. So now what will be your answer here? So now the given quantity is nothing but 0.4 moles. So 0.1 mole into, in 1 mole how many they have? 4. So you can write this as 0.1 into 4 into Avogadro number, so that it will gives you number of hydrogen atoms. Like here it will be moles. If I ask 0.4 mole, 4 moles of hydrogen atoms are there. Okay, this is your moles. If I ask you number of atoms, number of H atoms, 0.4 into Avogadro number. So that will be giving you Is this clear or not? So 0.4 into 6.022 into 10 power 23. So you can remove this, it becomes 22, 24, okay, into 10 power 22. This will be your final answer for number of hydrogen atoms. Is this clear or not? అర్థమైందా కాలేదా? అర్థమైందిగా అందరికీ? Okay. So now what is the generalized formula we got here? So number of moles or number of particles is equals to, what is the final formula? Number of moles into Avogadro number into that, see, atomicity. Here I am using like 1 carbon atom, here I am using 4 hydrogen atom. That is called what? So this is our third formula. First formula is weight by molar mass, gives number of moles. Second formula is given number of particles by second formula. Third one is number of particles equals to n into, that's it. Okay, that's it. You can write this. Okay, done up to here? Fast. So you need to try the question that I have mentioned previously. See, your preparation will be very smooth and very effective if you do maximum number of questions. Okay, just classroom lo కూర్చొని class వినేసి అయిపోయింది అనుకుంటే, అది అర్థమైంది అనుకుంటే కష్టం. You can't do in the exam. So whatever you have studied in the class, whatever you have listened in the class, practice the questions related to that as many as you can. Okay? Okay, and do not think for taking the help from others all the time. First you give your like work to your brain first. Done? Do this fast. B, okay. Number of oxygen atoms in, what is the first step to do? Quantity, grams is, weight is given now. First find number of moles of CO2. So it is 4.4 by 44. So it is how much? 1. So 0.1 mole we got. In 1 CO2, what they are asking? In 1 CO2, how many oxygen atoms are there? 2 oxygen. If it is 1 mole, it will be 2 moles of oxygen atoms. Yes or no? So here how many moles they have mentioned? 0.1. So it means 0.1 into that 2. This will be number of moles of oxygen atoms we got. So number of moles of oxygen atoms we got. Now number of oxygen atoms if I ask, 0.1 into 2 into Avogadro number. So it will be 0.2 into 6.022 into 10 power 23. So now what I can write, see, I can remove 1 0 from here and this is 22. So 12 into 10 power 22 we got. Can just check any option is there like this? See, 12 into 10 power 22 should be there. Is there any option like that? But if I write like this, 1.2 into 10 power 23. This is your proper representation. Tell me clearly, do you know how can we write these decimals here and there properly? Yeah, if you know, then you will get the answer. See how simple it is. Very small question now, but asked in the previous exam. Okay? Yeah, this is your answer. Done? Done with everyone? Yeah. Yeah, next one. Okay. Tell me for this fast. H12O6. Now what they are asking, calculate number of moles of carbon atom. First what you need to calculate? What is the gram molecular weight for these? 180 gram per mole. Next, what to do next one? First find number of moles of glucose. How many moles are there? 90 grams by 180 grams. So this will be 1 by 2. So you got 1 by 2 mole. Okay. So after that what I am asking you? I am not asking you number of moles of glucose. I am asking you carbon. In 1 mole of glucose, in 1 molecule of glucose, how many carbons are there? 6. So 6. Atomicity is how much? 6. Now what you need to do, number of moles of carbon atoms, if I ask, number of moles of glucose into atomicity. What is its atomicity? 1 by 2 into 6. So this gives you 3. How many moles of carbon atoms are there? 3 moles. Now if I ask number of carbon atoms, this number of moles into that Avogadro number. This gives you number of carbon atoms. Is this clear? Okay. Now if I ask you number of moles of hydrogen atoms, number of moles of oxygen atoms, what is your answer? So this will be how much? This is hydrogen is how much? Why it is 6? Because half mole you got for glucose into 12. So this is 6. And what about this? 3. So number of moles of carbon is 3, hydrogen is 6, oxygen is 3 in this many grams of glucose. Now if I ask total number of moles of all atoms, atoms means like this you calculate 12. That's it. Like that you can do. Okay, is this clear everyone? Yeah. Try this fast. Magnesium. Which are the following contains atoms equal to those in 12 grams of magnesium? So 12 grams of magnesium means how many? What I should do? atoms they are asking now. First find number of moles. Number of moles in what? Magnesium. See, 1 mole of any substance contain how many atoms? How many particles? 1 mole if I say, it will be Avogadro number. So you just find number of moles of that substances. If they have same number of moles, same number of atoms will also be there. Yes or no? Yeah. So now tell me this one. Given weight is 12 and its molar mass is 24. 1 by 2 moles of magnesium is there. You keep it aside. Now come to this. 12 by first. So this is 1 mole. Are they same? No. For what about this? Number of moles of nitrogen. How much it is? 7 by 28. So it will be 1 by 4. So now see, look at this. Be conscious. Look at this. So it is 1 by 4 mole we got. 1 by 4 mole we got. But they are asking about atoms. What is this? Molecule. So molecule to atom means convert, multiply with atomicity. So number of moles of nitrogen atoms equals to number of moles into its atomicity. So 1 by 4 into 2. So it will be 1 by 2. So can I say second option is perfect? Yes. Everyone clear? Okay. But most of you did wrong. I know. Why? Because you just taken it as N2 only. Okay? Because they are asking about atoms. You have taken it as molecule. So that's why you might be getting incorrect for some students. Okay? But you got the exact calculation now. So option 2 is perfect. Next, tell me for this one. 32 by 32. So this is number of moles of O2 you got. So it is 1 mole of O2. But I want atoms. In one molecule, how many are there? 2. So number of oxygen atoms if I ask, what you need to do? Number of moles into its atomicity. So 1 into 2. So it will be 2 moles of oxygen atoms. Okay. So which is a suitable answer? D. Next. So this is also a PYQ question. Okay, we'll come back to this again. So now one more thing I wanted to say here is, whenever they give you some quantity, okay, I will give the flow chart properly, you don't write, just listen. Whenever they give quantity like weight, first convert into number of moles. From this, you can convert them into number of molecules, number of atoms, or even number of electrons, protons, neutrons also. Okay. Now, let me tell you one question. I am giving you 6 grams of carbon atoms. What I am giving you? Otherwise, let me give you the same question that is asked in EAPCET. So 6 grams of H2O molecules are given. H2O is given. Then number of electrons present in it. This is the question they have mentioned. Tell me, what is your answer?
1 by 2.
Okay. So I will Ishwari. Okay, sir. Due to light, question is not visible. Okay. First, 6 grams of water means what you can make? First, they are asking number of electrons now. See, given weight, first convert into moles. Okay, 6 into 6 by 18. 1 by 3 moles we got. Okay, so now 3 moles of water molecule we have. Okay, so now what I am asking, number of electrons present. So number of moles of water we got like this. So in one water molecule, how many electrons are there? Electrons. how many electrons are there? How to do that? See, in one water molecule, how many hydrogens are there? In one hydrogen, how many electrons are there?
One hydrogen, 2 electrons.
What is atomic number? 1. So, 2 into 1 plus oxygen atoms are how many are there? 1 oxygen is there. Its atomic number is 8. So 8 electrons will be there. So total we have 10 electrons. So in one molecule 10. In 1 mole 10 mole of electrons. In this many moles, that mole into 10. So number of moles of electrons. What I am asking you know? Number of moles of electrons means what you need to do? Formula. Number of moles into number of electrons in one molecule, number of electrons. Okay, so it is 1 by 3 into 10. So this many moles are there, moles of electrons are there. So exactly if I want particles means wherever I have mole, I should multiply that with Avogadro number. Like this. This is your answer. Okay, you got what we are doing here? This is important model question that asked in the previous EAPCET exam. Okay, fast. Even if I ask for protons also, same steps. Instead of calculating electron, you just do protons. Next. Okay, let us summarize these formulas. Over up to here? Okay. So in the last class, I told you one more thing. What is that? Like at constant temperature and pressure. What is that? At constant temperature and pressure. Any gas you take, like what I am saying, you take any gas of same quantities. You are taking some 5 moles of O2 you are taking, or 5 moles of H2 you are taking. So at that constant temperature means at same temperature and pressure, if you are taking same quantity of any gas particles, they contains equal number of particles. Means quantity whatever you are taking. For example, 5 moles of O2 I am taking, 5 moles of H2 I am taking. So they contains equal number of molecules. What I am saying? Equal number of molecules. Okay. So if I change these values, the number of molecules also, it depends in the particular volume. So now here one more thing, at STP conditions, at STP, it means what is that condition I told you? Temperature and pressure. So temperature is how much? 273 Kelvin. Next pressure, 1 bar I told you. What I told you? 1 bar. So at these conditions, if you take 1 mole of any substance, what I am saying, 1 mole of any gaseous substance, any gaseous substance, any gas. So it will occupies 22.7 liters of volume. How much volume it will occupies? So you just remember this value. So 1 mole of any gas at STP occupies how much volume? 22.7. So here I am taking 2 containers. This is H2 gas, this is O2 gas. Okay, at STP condition only. At what condition I am saying?
STP condition.
Here I am taking this as 2 moles, this is also as 2 moles. Now tell me how much volume it has and how much volume it has? Both has same volume. What is that volume? Same means?
44.
See, 2 moles I told now. So 2 into 1 mole occupies 2 into 22.7 because 1 mole 22.7. So 2 moles like this. Okay, is this clear? Okay. Now one more condition is there, NTP. What is that condition name? NTP. This is standard temperature and pressure. This is normal temperature and pressure. So at NTP conditions, it means what are the specific values here? Same. 273 Kelvin. Pressure is 1 atmosphere is. See, there is a slight change in bar to ATM pressure. So that if we change any of this value, the volume occupied that gas particles also changes. It means 1 mole of any gas occupies 22.4 liters at this NTP condition. Okay, is this clear everyone? Will you remember this? Yes. Now, I am giving you one question here. 1 mole of N2 at NTP occupies how much volume? 22.4 liters. Okay. Instead of asking this question in this way, I am asking you 28 grams of N2 at NTP, how much volume it will occupy? 22.4 liters only. Why it is like that? See, 28 grams of N2 is nothing but 1 mole only now. So what is the relation? Number of moles equals to given weight by its molar mass. Given weight is 28, molar mass also 28, so gives you 1 mole. So it means sometimes instead of giving you moles, they may also mention in terms of grams. Is this clear? Is this clear or not everyone? Next, one more thing. Instead of saying 1 mole, I can say 28 grams. This is over. Instead of saying 1 mole of N2, I can say Avogadro number of N2 particles are given. What I am saying? Avogadro number of N2 particles are given. So, how much volume it will occupy at NTP condition? So, what is our center point in all the cases? 1 mole. So, you link 1 mole to the weight or 1 mole to the number of particles, 1 mole to the volume. Okay, is this clear everyone? Yes. Now, based on this, I will be giving you 7 grams of N2 I am giving you. 7 grams of N2 at NTP condition. At what condition? So tell me number of moles of N2, volume of N2 at this NTP condition, and also number of N2 molecules, and also number of nitrogen atoms. Fast. Fast. Everyone, don't. So tell me, what's your answer? So how can we do this? Number of moles means given weight is 7 grams by molar mass is 28 gram per mole. So it will be 1 by 4. So you got this 1 by 4 mole. Now what I am asking you? Volume at it should be always specified either NTP or STP. Then only these values will be taken. Otherwise values changes. Okay, now tell me what is your answer? 1 by 4 into perfect. So this will be how many times? 5 is 6. 5.6 liters. Now tell me this one. Number of molecules. How? What I told you? Number of moles into so N into Na. So 1 by 4 into this one you tell me.
1 by 4 into 2.
This one what I told you? N into Na into atomicity. So it means 1 by 4 into Avogadro number into 2. 1 by 2 into Avogadro number. So it means 3.011 into 10 power. That's it. Is this clear, everyone? Next, let us summarize this. Up to here it is clear now? First, who is main? Main character is number of moles, indicated with symbol N. Okay, let us put it in the box. Okay, now I have number of moles. I am asking you weight of the substance. What I am asking you?
Weight of the substance.
For example, I am giving you 2 moles of methane. Methane. How many grams it will be? 2 moles means.
32.
How can we do this? Number of moles equals to weight by molar mass we are doing. So now I am asking you weight. So number of moles into. So if I give you number of moles, how can you get this weight? What you are multiplying with? Number of moles into molar mass. Is this clear what I am making? Okay. So in the other question, I am giving you quantity of methane. Instead of saying 2 moles, I am giving you 16 grams of methane. So how many moles it will be? Or 32 grams of methane I am giving you. How many moles it will be? Given weight by? Now I am giving you weight in grams. So how can I get this number of moles? It means this number divided by molar mass. It means from here to here multiply. Here to here. Are you getting what we are discussing? Next, number of moles is done. I mean weight and number of moles relation is done. Next one is volume. Volume of gas at NTP or STP, you can take this side. Okay, now I have number of moles. Now how much volume it has, I am asking you. 1 mole occupies how much volume? So N moles occupies N into 22.4. So into 4 liters. Okay, now I am giving you volume of gas at NTP. How many moles it will be? Divided by? Yeah, so from here to here it will be? Okay, is this clear? Okay, next. Who is that? Okay. Okay, nice. You can ask like that. Okay, number of moles. See, 2 moles H2 at NTP I am saying. How much volume it will be? 1 mole means 22.4. So 2 means 2 into 22. So N means, N moles of H2 means N into 22.4. Is this clear? Okay. Now come back from there to this side. ఎక్కడ నవ్విన సౌండ్ వినబడుతుంది నాకు. Next, where we are? Moles to volume. Now from volume to moles. Now I am asking you, I am giving you how much? 11.2 liters of H2 at NTP. Now tell me how many moles it will be. Got what I am asking you? I given this quantity. So how can you do this normally if you don't know anything? Like see, 1 mole 22.4 liter. How much volume I given? 11.2 liter. How many moles I am asking? So X will be X into this number, this into this number. So 11 like 11.2 by, you got 1 by 2. Like this we are doing. So in the denominator what you have taken? So if volume is mentioned, the volume mentioned at NTP by volume of 1 mole at STP, that is 22.4. So you can divide that like this. Given volume by 22.4 liter gives you, is this clear? Erasing this. Okay, next. Up to here it is clear. What is the other relation we discussed about atoms, particles? So 1 mole of any substance contains how many particles? Number of entities or particles. If I ask, number of moles to number of particles, what we have related? Avogadro number. So if I give number of moles, you just multiply it with Avogadro numbers. If I want to include like atoms also, multiply it with atomicity also. Okay. Now I am giving you this, I am asking this. Divide that with Avogadro number and atomicity. Okay. See, atomicity you write directly. I think మీ కాన్సెప్ట్ వచ్చింది కదా. ఇప్పుడు ఇక్కడ అటామిసిటీ రాస్తే మీరు కన్ఫ్యూజన్ అవుతారేమో. జస్ట్ అవగాడ్రో నెంబర్ రాసుకోండి. ఓకే. సో డివైడ్ ఇట్ విత్ అవగాడ్రో number. Up to here is this clear? Okay, done. Okay, so now after the class what you need to do is just solve the questions first. See, very few students who are sitting here might have taken NEET coaching previously or JEE coaching previously. Very few students. Okay, for most of you it is fresh right now. So what you do is first you solve the same questions whatever we have solved in the class. Okay, and go through the notes that you have written during the class. Okay, just spend half an hour. If you want, you can spend more time also, but go through the same thing, okay, and do the same thing whatever we did. Then go through the new questions. Okay, we have lot of questions here in the board itself, like I am giving in the study over time now. You can solve them, or within 1 or 2 days you will get that books. You got the books? Yeah, so you can solve. You can solve from it. Okay, done up to here. Make this table in your books. Fast, done? Done up to here? Yeah. Write one question. Okay. Write everyone. 60 grams of ethane. How many grams? 60 grams of ethane is given. 60 grams of ethane. What is the formula of ethane? C2H6. 60 grams of ethane is given. Then calculate number of moles of ethane. Next, number of moles of ethane, number of particles, number of ethane molecules, number of ethane molecules, okay, and volume of ethane at NTP, volume of ethane at NTP means how many grams are given you? 60 grams now. So if you take 60 grams of ethane at this NTP condition, how much volume it will occupy? That is what I am asking you. Okay, and after this, number of moles of hydrogen atoms. What I am asking, number of moles of hydrogen atoms. Okay, that's it. Up to here you do this many questions. How many? 4 questions. Sub questions are 4. Okay, do take this as a homework. Okay, you try it and you can show me in the study over time or whenever it is possible. Okay, but everyone should do. I will ask you randomly. Okay, and remember, Sir told that he will ask in the class and he will shout on the faces. Don't think like that. Okay, it's completely up to you. But as my duty, I am giving the questions. You need to practice. Okay, if you have any doubt, you ask me. Okay, don't skip the class due to that sir is going to ask the question in the next class. Okay, next. Next, this one. So, okay, before this, we have one more thing. Percentage composition. Percentage composition means it is of 2 types. One is by mass percentage, by mole percentage. I will take one simple example. You just follow this, whatever I am explaining. See, by mass, let us discuss first. Percentage composition means weight of the component by total weight into 100. What I am saying? Weight of the component by so here if you want you can write percentage of component. Component means what? For example, I am taking methane. What I am taking? Methane. So in this methane, what are the components we have for making this methane? Carbon and hydrogen. Now percentage composition of carbon, if I ask you, weight of carbon, total weight of compound. Is this clear up to here? Into 100. So now tell me 12 by 16 into 100. Is this clear? Yeah. So this many times, how many times? 3, 4 3s are 4s are. This one 25. So percentage weight of carbon is how much? 325 is a 75. So 75 will be your percentage of carbon. Is this clear what we are doing? Okay. Similarly, if I ask you for percentage of hydrogen, 4 by 16 into, that's it. Yeah. So you are going to get it as how much?
20.
Okay, 25. Okay, so now whenever it is simple, whenever there is only 2 materials, 2 components, if you get the one component, 100 minus that component gives the remaining component. Like 100 minus 75 will be, but if they specifically mention like 3 4 are there, it is better to do separately like this. Okay, is this clear? Okay, so this story will be when in terms of mass. Now let us talk in terms of moles. Okay, so by mole means percentage composition by mole. It means what you can say? What you can say? Number of moles of a component by total number of moles. Okay, same example I am taking here. So methane I am taking now. So in 1 mole of methane, this is a previously asked JEE question. Okay, so in 1 mole of methane, how many moles of carbons are there? In 1 mole methane, how many moles of carbons are there? 1 mole carbon. In 1 mole of methane, how many moles of hydrogens are there? 4 moles of hydrogens. Now total moles if I ask? 1 plus 4, 5 moles. Up to here it is clear now? Next, percentage composition of carbon by moles. By mass is different, by moles is different. Now tell me how many moles of carbon, component carbon is how much? So numerator is how much, denominator is how much? Here 1, here it is 5 into 100. So this will be how much? 20. Next, percentage composition of hydrogen if I ask? 4 by 5 into 80. Is this clear? Okay. So if they ask you by mole, follow this method. They ask you by mass, follow this method. Is this clear? Yeah. Done. So these 2 questions are more than enough for understanding. Next. Zuma. సరిపోద్దా? Okay. Next one. There is something called empirical formula and molecular formula. What is that? Empirical formula and molecular formula. See, what I am writing here? CH2O I am writing. Okay. So now here I am writing one more formula, you just check. C2H4O2. Okay, I am writing one more formula, you can see. C6H12O6. Now what is common in these things? I mean these three molecules? CHO. Okay, so now here there are term called empirical formula, molecular formula. Empirical formula means the simplest whole number ratio of all the atoms present in the molecule. Okay, so here what is the simplest way I can write this molecule? This is the only simplest way I can make. Okay, but here what is the simplest way I can write? CH2O taken twice. So I can remove this 2 from here, that means it is the simplest whole number ratio. From here you tell me CH2O 6 times. That's it now. Now what is the simplest ratio in all the cases here? CH2O, CH2O, CH2O. Okay, so now the simplest ratio here, the empirical formula here is CH2O. Now see, actually you know what is this compound? I can say this is a formaldehyde. What is this? Formaldehyde. About this one, this is like I can write acetic acid, CH3COOH. What about this? Glucose, you know. Okay, so now this is glucose I am writing. No need of writing structure, it's big. We'll do it later in biomolecules. Okay, so this is acetic acid, this is glucose. See, different molecules, different compounds have different chemical formulas, but empirical formula may be same. Okay, so how can you define an empirical formula here? See, an empirical formula represents the simplest whole number ratio of various atoms present in the compound. So this is the simplest way of representing it. So for this also it will be same, for this also it will be same. Okay, so now if you observe, whenever I have only empirical formula, by multiplying it with a specific number, I will get its molecular formula. So I can simply make like a statement like this: empirical formula multiplied with some number gives you. Okay, so it means, so what is that n value in this case? What is the n value in this case? 2. Here it is 1. Okay, is this clear? So you got molecular formula equals to n into empirical formula. So now n can be 1, 2, so on like that, 2, 3 like that. Okay, is this clear? Okay. Next. Okay, up to here everyone done with this? Yeah. Just write this formula, that's it. In your mind there should be like empirical formula means simplest whole number ratio of all the atoms present in a compounds, whereas molecular formula shows the exact number of different types of atoms present in the compound. Done? Okay, let's move forward. Just see this question, this is a NEET question again. See, they are saying there is a compound X. Okay, it contains, so percent, it means what? Percent means for 100%, like 100 gram, like for 100 grams, how many grams of A is there? Like that. So this compound X is made with A, made with B, and also with C, and its percentage is 32, it 20, and here it is remaining is C. Out of 100 grams, see, let us say compound is 100 grams, 32 grams of, then remaining grams is C. How much it is? 52 means 100 minus 50 2 means 48. So you got these quantities now. Now using this we need to say what will be the empirical formula of the compound. We need to say out of the 4 options. Okay. So empirical formula means what we know? The simplest
Whole number ratio.
so that whole number ratio should come. Okay. So now when what is this quantities I can say now? Grams. Like for 100 grams I can say 32 grams these like this. Okay. Now I have grams now. Convert into its number of moles first. So given weight by its molar mass. So now 32 by
64.
they have mentioned this 1 by 2 and similarly for B 20 by this is also similarly for 48 by sorry 30 given weight by molar mass. So 48 by 32. So this will 16 3s are 2s are. Okay. Now what is A here we got? A how many times? A is 1 by 2. B is also C is 3 by 2. See 2 2 2 here common now. Now what we require? Whole number ratio, simplest whole number ratio I can get. So if I consider this as a molecular formula, so what is the empirical formula I can make out of it? A, B, C, 3. So what I have taken common outside? 1 by 2. So remove this. So whatever the simplest form is there, that will be your, this is your option. Clear everyone? Okay. Write it. Yes, tell me ma. Huh? అడిగండి 32 molar mass is how much? I mean C molar mass is how much?
32.
So molar mass in the denominator, and what is the weight of C? 48. How we got 48? That's up to here clear whatever we discussed? Yeah. Okay. Want to write fast? Then next, yeah. So from here you can expect the question again. Chemical equations and stoichiometry. So what I told you stoichiometry means? After the balancing an equation, whatever the coefficients you will get, those are considered to be stoichiometric. Stoichiometry, it means, metry means like measure of elements. What we are doing, we are measuring the elements or measuring the quantity of compounds formed during a chemical reaction. Okay. So see here, it is calculated, it is the calculation of moles, masses, volumes of reactants, products involved in a chemically balanced. Next, let us take 1-2 examples, like go with simple example, methane combustion will go. So how many moles of carbons? Here also 1. Hydrogens, I mean 4. So here it should be balance it like that. Okay, we already did the same example, that's why I am doing directly. Okay, oxygens, how many are there this side? That's it, done. Now what is their mole ratio or stoichiometric coefficients? 1, 2, 1, 2. So these are called stoichiometry coefficients. Okay. So first write the balanced equation, take their stoichiometric coefficients and find out what the relation as per this. Okay. It means what it is saying us, see, generally writing something means it's a theoretical thing or not. We are writing it theoretically. But when you do experiment, we can think that during the experiment also this might be followed. So theoretically you are getting, like for combustion of 1 mole of methane, how many moles of oxygen required? 2 moles. And how many moles of carbon dioxide is formed? 1 mole. Water? This is our theoretical assumption based on the balanced equation. Okay. So now when we do practically, when we do experiment, real experiment, so it almost looks like this. It will not be greater than this. Okay, greater than means amount of product formed, I am saying. See how many moles of carbon dioxide is formed? So the product formed, experiment if you do, it will not be greater than this theoretical one. Whatever the theoretical yield you got, it will not be exceeding this 1 mole. It will be definitely equal to it, or it is simple. You are planning something. ఈ రోజు ఒక చాప్టర్ కంప్లీట్ చేద్దాం అనుకుంటున్నాం. ఓకే, బట్ మోస్ట్లీ ఏమవుతుంది, చేస్తారా? మ్యాక్సిమం లెవెల్ ట్రై చేస్తే రీచ్ అవుతారు, లేకపోతే దానికన్నా తక్కువనే చేస్తారు. ఓకే, ఎక్సెప్షనల్ అయితే అది ఎక్సెప్షనల్ కేస్, ఇంకా దాని గురించి మాట్లాడట్లేదు నేను, జనరల్ కేసులో. సో ఆల్వేస్ ఎక్స్పెరిమెంటల్ yield will be less than theoretical yield. Whatever you are getting theoretically, that will be always greater than your experimental or the practical yield. Just remember about that, we will study later. Okay, up to here it is clear now. So first find the mole ratio. So now if I say 1 mole, how many grams it will be?
60 grams.
What about this? 32 grams means it is 1 mole, but 2 moles means 2 into 32, 64 grams. What about this? 1 into 44 grams. This one 2 into 18, 36 grams. Now you need to understand that here to here, here to here, here to here, it is a mole to mole ratio. What is this?
Mole to mole ratio.
Mole to mole. Like I can connect mole to mole ratio, and from here to here, see 16 grams of methane requires how many grams of oxygen?
64 grams.
So I can relate weight to weight ratios also. Okay, so I can relate weight to weight ratios or mole to mole ratio. Or in the other words, I can say mole to weight ratio also. It means 1 mole of methane requires 2 moles of oxygen, I can say, or 1 mole of methane requires 64 grams of, and that will form you 44 grams of and 36 grams of. Up to here it is clear, na? And one more thing, if you observe, there is something called law of conservation of mass. What I am saying?
Law of conservation of mass.
It means whatever the amount of starting material you are taking, same amount will be there at the product side. It means the amount of reactant, the mass of reactant will be equals to mass of products. So now calculate sum. What is the sum of these two things? 16 plus 64. 80. This one? 44 plus 36 is how much? 80. So the quantity of reactants and quantity of products are equal. So this is called law of conservation of mass. Okay? Is this clear, everyone? Yeah. Okay, up to here it is clear. Now I am giving you a question. ఏమైందమ్మా నవ్వుతున్నా అన్నారు? For 8 grams of methane, 8 grams of methane, upon complete combustion, produces X grams of CO2 and Y grams of H2O. Now tell me what is the values of this X and Y. You got what I am saying? Once read the question properly.
8 grams of CH4.
So what to do first step? Write the balanced chemical equation. Take that mole ratio. After taking the mole ratio, 1 mole of starting material, like 1 mole of methane means you have written? Like that. Take 8 grams means how can you write it? Half mole. So like that, or whatever the way you got, you just try it. I will tell you again. Yes, super. Excellent. Okay, nice. It's a very simple question actually. So how to write this? Tell me. CO2, methane plus O2 gives you first balance. Next 1 2 1 2. So here how much I mentioned? See, my answer should be in grams. So it is better to convert moles into grams. So 1 mole of methane means
16 grams.
2 moles of O2 means 64. Now what is the quantity of methane I given? 8 grams. So here 16 grams means how much quantity produced? 8 grams means
22.
so 22. Again, if you are unable to do that, see, just take it as x. That unitary method concept is there now. So if you take this as x, so you will get 16 into x equals to 8 into 44. Okay, this will be 2 times, this will be 22 times. So x will be 22 grams. Okay, you can do it like this, 22 grams. Okay, you got what I am saying? Otherwise, from here to here, what is the change? You divided with 2. There also you divide this number with, so that is 22. Now, tell me, 8 grams produce how many grams of water? How many grams? 18 grams. Okay, just got everyone? Okay. Now, one more question you write. To this question only I am extending little bit. Here I asked you about CO2 and water. So now how many grams of oxygen is required for complete combustion? For same question, for same quantity. See, for 16 grams, 64. For 8 grams, 32. Perfect. Next. Okay. So I am saying 60 grams of ethane. How many grams?
60 grams of
Ethane. Given. Then moles of O2 required and weight of CO2 formed and weight of H2O formed upon complete combustion. Tell me fast. What's the answer? So what to do? First step, I am not going to explain anyways, but just for hint, those who are really troubling. Yeah, tell me. First write the balanced equation. Then next, here I am asking you mole also now. First find the mole ratio. Okay, so 60 grams means convert into 60 grams of ethane means how many moles? Find. What is the molar mass of ethane? Ethane formula is what? So 30 grams you got molar mass. So number of moles is given weight by molar mass. 60 by 30. 2 moles. So for 1 mole, how much oxygen required? For 2 moles, how much is required? That's it. That is your first question answer. Next one, CO2. Same mole ratio, find it and get the answer. Okay. Got anyone? 7 moles of oxygen. Anyone? Same answer? Okay. 44 grams. Just 44 grams of CO2? check it properly.
88. CO2.
Maybe that bigger number will come, that's it. Okay, so tried everyone. Yeah. So, okay. So first balance this. 2 carbons, 2 carbons. 6 hydrogens, 6 hydrogens. Oxygens, how many are there? 4 plus 3, 7. So here if I take 7, it becomes, but if I take the 7 by 2, see 7 by 2 into 2, 2 cancel, we have 7 oxygens. Like this you need to balance it first. Is this clear everyone? Yes. Yeah. So now what is the mole ratio you got? For 1 mole of ethane, you required 7 by 2 mole of O2 forms 2 mole and 3 mole. You got mole ratio as per the balanced equation. Now how much quantity mentioned? 6. So given, this is as per the equation. Given, how much? 60 by molar mass is 30. So this is 2. So for 2, it will be how much? For 2, it will be, for 1 this much. For 2, into 2. So 2 into 7 by 2. So it means 7 moles. So what is your answer for this? 7 moles. See, 1 mole forming how many moles of CO2? 2. So 2 moles will form? 4. So 4 moles of CO2. So but I am not asking you mole. So what to do? Weight means what to do? Like number of moles into Avogadro, molar mass. How much? 44. So 16, 1, 16, 1, 76. Everyone? Nice. This one? So 1, 3, 2, 6. 6 into how much? 1 not? That is your answer for the question. Okay, everyone got this? Yeah. Okay, let me give you 1, 2 questions. Then almost. So one more concept is there, limiting reagent, excess reagent. We will discuss that in the next class. Do this fast. You know ammonia reaction? N2 plus H2 gives rise to NH3. Balance that equation. Balance it first. చెప్పండి మళ్ళీ. So N2 plus 3 H2 gives rise to 2 NH3. As per that you do this question. How many moles of ammonia produced by 5 moles of hydrogen? Okay, you try this. And one more question. This is question number 1 as a homework, and question number 2. Okay. 48 grams, okay, it is difficult, okay. 15 grams of ethane upon combustion, upon complete combustion, gives X grams of CO2 and Y grams of H2O. Okay, so you just try these 2 questions, and for the remaining things you just go through the notes or material whatever you have. If not, I will be giving you some questions after this class. Just solve those questions. Okay, remaining we will discuss in the next class. Okay, tomorrow we will be finishing up this chapter and we will be starting periodic table. Okay, so don't skip the classes, try to be present so that you will feel full clarity about the sessions that we are conducting here. Otherwise, if you skip one class, so your mind will say like, yeah, you missed yesterday's class, that's why you are not able to follow today. So it will keep on continue. Okay, so don't skip, be present, that's it.